granary. And the bucket system we found at a conference here in Germany. All three structures use different systems to distribute moisture. So the second wall has a large sheet of cotton cloth going throughout the center of the system. The planting tower has 3 plastic tubes with holes in them, also filled with cotton cloth and gravel. And the bucket system uses a drip irrigation system by alternating water and soil buckets. We built 2 structures per location, and you see this wooden wall in the photo. On one side is north side facing and the other side is south side. So we wanted to see which location would affect plant growth most. We measured soil moisture and temperature, and we tested 3 vegetables and 1 legume from the 4 main plant families consumed in the area. So we tried out field peas, African spinach, black nightshade, and collard greens. And all 4 were each planted in each system, randomly allocated to positions. So we found that the planting tower and the second wall have significantly higher yields in total amounts in the top graph of all vegetables planted, whereas in grams per meter squared, the planting tower showed the lowest yield since it had the highest surface area, whereas the wall showed to be most efficient with space for all of the different vegetables planted. All green leafy vegetables produced yields except for the field peas. They took too long. And at this point, it's also important to mention the time when we were in the field using these systems was a drought season. So there was very little water available, which also actually speaks to these systems because we didn't irrigate. We only used rainwater, and green leafy vegetables were still flourishing. There was no significant difference between the north and the south direction. To conclude, the vertical gardens are a viable possibility for producing more vegetables in the home garden. We focused on available and recyclable materials that are found in the area, like broken bottles, sticks, strings, and things like that, and that worked really well, so that focus can remain. However, we need more research on how many seasons one system can support, how to add fertilizers or organic residues, what's the best way for that, and how to improve the irrigation, so maybe we can even spread the growth of these vegetables past the rain season. So to finish, I'd like to thank our donors and particularly Fiat Panis for helping us and financing us for this study. Thank you.
Thanks, Sarah, for a very interesting talk to your poster and a very nice topic with beautiful illustrations. There's no question on the Q&A, but I surely have one. Did you also measure soil temperature or substrate temperature in these devices, as I would expect them, at least under some conditions, to basically increase to a higher level where then roots can suffer, and of course also processes in the soil are increased?
Yeah, so we measured soil temperature and soil moisture. And again, it was the same as with the yields. The planting tower and the second wall, so the first and the last picture you can see on this slide, showed very constant conditions. Of course, there were differences in the height. So it was drier at the top and a bit wetter at the bottom. But through the cotton cloth actually worked really well and distributed that really well. The buckets got the hottest, but there was really little fluctuation. We'd expected a lot more. And we expected to see more in the north-south direction as well, but no, the differences weren't significant.
All right, thank you very much. Yeah, very interesting. Are there any other questions from the other presenters of this morning's session? Obviously not. Do you have any idea where we can consider installing these devices, and if there are additional benefits? So coming from having an engineering background in civil engineering, do you think there is also possibility of improving living conditions in houses, in huts, using these devices to kind of manage temperature indoors?
Yeah, I mean, these systems, or generally like the urban gardening, has so many ideas and it's so open and so creative.
Yeah.
Like yesterday, we heard in the presentation that you can paint your roof with some chemical to make it white so that the sun reflects and it doesn't get so hot. But theoretically, you can just also plant your roof and that will keep your roof cool as well. Or like these systems, we thought that you could put them directly next to the kitchen or next to the home so that you don't have to walk far to get vegetables either. Or you could just plant an entire wall of your house, and that would cool down the wall as well. I mean, like these urban gardening and vertical gardens are already used now here in Europe in cities to cool down buildings.
Exactly.
So that would definitely be an option. They use it a lot in refugee camps as well because of the tin
Good morning
roofs.
to all.
Yeah.
They plant like
I am
big
Dr.
leafed
Dheeraj Singh from
things
Central
or big
Arid
leaf
Zone.
vegetables on top of the houses in refugee camps to cool.
Yeah, beautiful. Thanks, Sarah. It's a very interesting talk. And again, looking forward to seeing some more of these devices being installed in different parts of the world. So we continue with the next presentation. We skip the poster by Dheeraj Singh. Let's see, did not show up, was she? And we continue with the presentation by Christine Alum on smallholder farms characterization and the use of productive resources in Mount Elgon, and we stay in Uganda. Christine, can you please share your screen and upload your brief presentation? Okay.
Good morning, everyone. Let me try to upload to share my screen.
There's a symbol at the bottom. If you go down with your cursor, then it shows up share screen.
Yes.
Yeah, and if you click that, you should be able to share your screen. Here we go.
Hello.
And now if you go on presentation mode, then I think it runs perfectly. Beautiful. All right, so then we start the 3 minutes for your presentation.
Okay, good morning, everyone. My name is Christine Alum, and this is our poster on smallholder farms characterization and the use of productive resources in the Mount Elgon region in Uganda. The study was specifically carried out in Kapchora district in the eastern part of Uganda. And the aim of the research was to explore the relation between production diversity of farms and their resource endowment. And this was done so as to be able to construct typical farm models. In the study, 108 farms were classified based on their production resources and also strategies using principal component and cluster analysis. So in our second slide, we can see from our results, principal component 1, which was referred to as the land resources, explained the highest variability amongst the farm types. And these land resources was included land accessed by these farms, the size of land cultivated by these farms, and also the number of fields owned by these farms. In this slide, we can see 3 farm types were identified, and that is the poor, the medium, and the high resource endowed farms. So the medium resource endowed farms had a relatively high production diversity, and they also had the highest labor input in crop production. So I can conclude that production diversity was low in the poor resource farms, and therefore directing intensification interventions in these low productive farms could help to increase production diversity. Thank you very much for listening.
Thank you, Christine, being well in time and the brief presentation of your poster. Are there any questions? Let me quickly update the Q&A session, as it doesn't do that automatically, at least on my laptop. Not yet. Can you maybe give us some examples of these intensifications which you consider?
Okay, so we can when we are looking at directing like intensification interventions, for example, we can say these farms could practice
Hi everyone,
like
I'm
mixed
Solomon.
cropping practices, whereby they can grow a number of crops in a smaller piece of land, since they are not well endowed in land resources. So if they can plant more crops in a particular piece of land and also use other soil enhancing, for example, fertilizers or manure. So those are some of the intensification strategies we're looking at.
Okay, thank you very much. Are there questions from the other presenters here at this stage? There's one question in the Q&A session, which I would like to forward to you, Christine. Do farmers sell to local markets, or is it subsistence farming?
Okay, as we have identified our 3 farm types, so some of the farmers do sell to the local market, and some of them also do only for subsistence. And this is also based on the different farm types, because based on their resource endowments, those who only use it for the food for subsistence are the ones who are poorly resource endowed, or who do not have access to other resources. So the different categories also include their production orientation. So we have the poor resource endowed mainly concentrating on subsistence, and then the high resource mainly do for the market, produce for the market too.
Okay, thank you very much, Christine, again for your presentation. And I'd like to continue. We have some time at the end to raise further questions and maybe continue the discussion. But I'd like to continue now with the next presentation by Solomon Araya, where it's about assessing wastewater irrigated urban vegetable production and market systems in Ethiopia. Solomon, can you please share your screen and give us a brief introduction to your poster? Okay, if you go back to the first one, that's beautiful. We can't hear you yet. Can you switch on your microphone?
It's okay.
Yeah,
Can
now
you hear me now?
if you can start the presentation mode of your presentation. Here we go. Beautiful. Okay, I'm looking forward to you.
Thank you very much. Hi, everyone. I'm Solomon. Together with co-authors, I welcome you to our poster, Assessment of Wastewater Irrigated Urban Vegetable Production and Market System in Ethiopia, in the case of Agagi River in Addis Ababa. And the significance of the study is to improve the knowledge base of stakeholders and provide a baseline information for further studies, and to know the perception or how the producers and consumers think about the production system. And to do this, we use both primary and secondary data collection. And we have interviewed about 75 vegetable producers and 40 consumers around the region. And we have also considered some government policies and published or unpublished research and some water tests. Yeah, the producers mainly plant about 12 different vegetables on small plot land and throughout the year. They use crop rotation and they harvest 3 to 5 times per year. And the producers may have their own farmland, or they may rent it from other farmers. And wastewater vegetable production is a main source for of income for more than half of the producers, and it plays a great role for their food security for both the producers and the consumers. The producers use different irrigation systems like furrow, drip, buckets, and so on. And all the irrigation water comes mostly from industry disposal, and all producers agree on the existence of pollution on the river or on the irrigation water. Something to the market channel. Vegetable producers use their products both for own consumption and as a cash crop, and they use different market channels to sell their products. There is a huge price difference when the vegetable is sold at the farm level or at the market. And by the way, female farmers get more profit than the male farmers, because most of them sells their directly to the end consumer on local markets and so on, or on the street, on the roadside marketing. And due to the water source irrigation and other the occurrence of sickness is high. The level of physicochemical parameters of the water is much higher compared with the standard of the surface water. So to the conclusion, there is a conflict of interest. I would say, on one hand, the sector sustains the livelihood of a significant of urban population to the food security and income through this vegetable market channels or throughout the value chain. On the other hand, there is the issue of health, due to the consumption of these vegetables.
Okay, Solomon, thank you very much. I think your poster is also available online. Thanks again for your presentation. And we have time for 1 or 2 questions. So let me again check the Q&A session. The question is to you, Solomon. Where does the wastewater come from? What has the water been used before?
Are you hearing me?
Yeah.
Yeah, the water comes from different sources, mainly from industries, disposals. I don't know if you could see this PowerPoint. And it comes also from households level. So they dispose their wastes from toilet, and some part comes from community institutes, from schools, from health sectors. So they directly let the disposal the wastes to the river. So about 67% comes from industry, about 25% from individual households, and about 8% comes from community institutions.
Okay, is this water in any way cleaned before it is used for vegetable production?
As far as our data, no. It directly goes to the river, and the farmers use directly from the river to their farmland.
Is there any investigation on the load of potential risks, such as heavy metals? Some of them may end up on the field, or organic pollutants, or if you mentioned that some of the wastewater comes from households and also from the health sector, I would expect that you also have an issue with human pathogens and antibiotic resistances.
Mm-hmm. If you could see on the poster, there is a table comparing the physicochemical parameter tests of the river, and it compares with the standard of surface water, like pH, the nitrate, ammonia, phosphate, and different kinds of parameters. So the value from this test are much higher than the standard for surface water. So we had the chance to have a look on different water tests, and there is a huge difference between the standard and the test of this river.
Okay, I would still be worried when looking at this data, because it doesn't give me an idea about the true risks, which I would expect to be really human pathogens and antibiotic resistances. So I highly recommend in the future to also consider that in wastewater and treatment system. Solomon, thank you very much for a very interesting presentation. And I think there's a possibility to contact each and every of the presenters personally to continue with that discussion. And we move on with our next presentation by Surua Gorandel, where it's yet about another topic, looking at saffron mallow intercropping patterns. So Surua, can you please upload your presentation, and all the other contributors here, can you please switch off your microphones once you're not presenting, so we can avoid any disturbance by wind or kids or animals in the background. Yeah, so, okay, Suru, can you share your screen with us, please?
Okay, good morning. Hello, everyone. Can you share my presentation? I can't share it because I am with my phone and I can't access it.
It unfortunately doesn't work from the WhatsApp. What I can do, I can share the poster. Let me quickly
Thank you.
change the mode. Okay, let me see if I will be able to do it. Can you see your poster?
Thank you.
Yeah, okay. Then you have 3 minutes, and if you hear the sound, then please finish your last sentence. Yeah, here we go.
Hello, good morning. My presentation is about effect of saffron and Molo intercropping pattern in the third year on possible cooling of corn for climate change adaptation. As you know, saffron is a member of Iridaceae family, is a fall-flowering geophyte plant, and has an important role in agriculture, economy, and rural farming system, especially in semi-arid region. Intercropping has an important production systems for many years, and companion crops help to cover soil and avoid loss of water and nutrients. So the current study was aimed to evaluate the effect of saffron and Molo intercropping on flower and corm yield and quality of saffron. This experiment was conducted based on a randomized complete block design with 3 replications in Firdaus University of Mashhad, Iran, during 3 years. Treatments were 15, 30, and 45 and 60 centimeter row spacing for saffron from Molo planting rows and their soil cultivation. All agronomic operations were done according to the local practices. As a result, the effect of row spacing for saffron from Molo planting was significant on fresh flower yield, flower number, dried weight of stigma, and dried weight of corm of saffron. As you see here, the maximum value was for sole saffron cultivation, but amongst the intercropping treatments, the maximum value was related for 30 centimeter row spacing in intercropping pattern. Intercropping saffron with Molo enhanced growth and yield of saffron due to decreasing soil temperature. Flower induction of saffron directly affected by temperature. So that high temperature during summer had negative effect on flowering. But crossing and saffronal content of saffron were not affected by row spacing because they are secondary metabolite and they control by genetic characteristic, not agronomic management. Also,
Okay, please come to an end.
The maximum value for was computed for 13 centimeter spacing in intercropping of saffron with Molo. Thanks for your listening.
All right, thank you very much, Soro, for your presentation. And I have to quickly get back to my normal mode to check again the Q&A session if there are any questions. Okay, here we go. It's just, okay, there's no question yet, but I have one question. What are the benefits for the farmers of changing to this intercropping system?
There are many cropping systems in Iran for saffron in soil culture and cultivation, but many different plants such as medicinal plant. Medicinal plant have created many ecosystem services and goods for rural system, and it's good for them.
Okay, thank you very much. Again, I will check the Q&A session if there are any questions. No. And then again, Sarua, thank you very much for sharing your results. There's a possibility contacting you. I think your contact details are also on the poster. Please, all of you, can you check if your poster is, if you are able to access your poster on the Tropentag website? I think there were some issues here and there with the PDF documents. If you have problems, contact the organizers. Okay, let me quickly check the list of participants. I think we move on with the poster that was meant to be the second one by Dr. Dheeraj Singh on opportunistic adaptation of conserved moisture for food sustainability in arid zones. Dheeraj, can you share your screen and show your presentation? And again, all the others, please switch off your microphones while Dr. Singh is providing his presentation.
Full screen.
Okay, so if you go into presentation mode, please, then we can see your main slide. Okay, here we go. You have 3 minutes, and then I set an alarm clock, so you then should finish your last sentence here. Looking forward to your presentation.
Yeah, good morning to all. I am presenting a very interesting topic on opportunistic adaptation of conserved moisture for food sustainability in arid zone. And I am from India, from Central Arid Zone Research Institute. Regarding the outline of my presentation, this particular case study pertains to Pali district in Rajasthan, which covers under semi-arid zone. The soils are saline to sodic and the water has high pH and high EC. But during rains, there is plenty of water as runoff, and all the reservoirs and all the rainwater harvesting structures, they get filled up. This water slowly and slowly dries due to leaching and evaporation. So the farmers see a very important opportunity in utilizing this water for winter crop as well as very early summer crops. So keeping these points, a study was conducted to examine the adaptation of the conservation agriculture principles, mainly to muskmelon in this arid zone. Regarding the mode of study, the materials and the method, a sample of 120 representative respondents, they were selected randomly for the study purpose. They were utilizing this particular technique of conservation moisture for muskmelon cultivation. And the data was collected through a personal interview schedule, specially prepared for the present investigation, and it was subjected to appropriate statistical analysis. This is a view, that is, this is the preview before the monsoon, that is the soils, they are cracked and they are extremely dried up. And this is the second view where you can see that these are the mountains and they are at the back side, you can see plenty of water. So when slowly and slowly this water dries up, so farmers come in the field and they start preparing their conserved principles on muskmelon crop. You can see that the farmers, they are sowing the seeds by digging the pits and mixing little bit of sand and organic manure. Here you can see that the farmers, they are doing the planking operations with the help of tractor and a planker which is mounted at the back side of the tractor. This is a very important operation. That is, it opens up the space. The plants, they get plenty of moisture as well as air for their nominal growth. And as you can see that after this operation, the vines, they grow very fast and they start flowering and fruiting. So this is a very important operation. Coming to the results and the discussion, when we compare the muskmelon cultivated on conserved moisture and similarly the same variety which is cultivated on irrigated conditions, we find that the plants and the conserved moisture, they perform very much better with long roots.
Can you please come to an end? Your time is over. Please come to your concluding sentence.
Yeah, surely, sir. So regarding the yield parameters, the roots are longer and they take less time for planting, flowering and fruiting. And similarly, the adoption parameters also indicate that the farmers, they are having a plenty good adoption of these techniques. And regarding coming to the end, that is the farmers, they are adopting this technique and it is a boon to the farmers in the arid zone. Thank you all.
Thank you, Dr. Singh, for sharing this these interesting results. We have time for one or two questions before coming back to discussing or allowing questions to all the talks. There's no question on the Q&A, but I surely have one. Can you give us a short idea about the level of salinity these soils have and the level of alkalinity? You mentioned they are saline and alkaline, but to what extent? What are the ECE values and what are the pH values?
Yeah, actually, these parameters are very much variable. The soils, they are having a pH of more than 8, that is, it goes from 8.5 to 10.2. And regarding the EC values, they are highly variable, means the common EC values start from 3 and they goes up to 18. So these two parameters, they are highly varying. So with the onset of the monsoons, the EC as well as the pH, they are under growing limits. But with March onwards, as the heat increases, the temperature increases, the salinity level as well as the EC level, they also goes beyond the germination capacity. So this early adaptation of this particular technique, it is really a boon for the farmers.
Yeah, so you have also specific varieties which cope well with these rather extreme conditions of high pH and salinity, I guess. There's one
definitely.
Q&A session related to the structure. As far as I understood, it's a dam which is flooded during the rainy season, right?
Yeah, these are local level dams, and there are a number of dams here and there in the entire district where farmers, they are having their lands within the dams.
Is it possible to create more structure in these landscapes by planting trees or hedges, or will they be completely flooded or moved away by the floods?
Actually, planting of trees is not possible because these lands remain submerged with the water for more than 2 months or 2.5 months. So if we plant trees, they will dry up due to this stagnation. So only thing is utilization of this conserved moisture for growing your winter crops as well as your summer crops.
Okay, and one last question is from the Q&A session again. Is soil erosion a problem in this area during the monsoon period?
Soil erosion in this area is not a big problem because actually these reservoirs, they are plenty and they are scattered. So they don't allow the water along with the soil to move here and there with great velocity.
As far as I understand, it's rather the areas where the soil accumulates, which is eroding away from other parts, right? So it's the low-lying areas where the dams are created and where you have collection of soil. I would get more worried about the soil structure if I look at some of these pictures. But anyway, maybe I have a chance to come to visit at some stage. Dr. Singh, thank you very much for your contribution. And I'd like to have some few minutes, which we have left, to come back to some of the other talks. So, Dr. Singh, thanks again for your presentation.
Thank you all. Thank you.
And there was one question to Sarah, which I only realized a bit too late, sorry. And the question was, Sarah, how did farmers accept the proposed vertical garden systems?
So thank you for that question. We're actually not sure how farmers would react to it. We built the systems in schools in the area. So we know how the students reacted and the teachers, and they, all of the schools where we built these systems, they asked whether they could keep them. And we were planning to go back a year after, or like 6 months after we left the systems there. So actually kind of now to see how they were faring and to see whether they were still in use and whether they're being maintained and so on. But due to COVID, the schools closed. So we're pretty sure that they've all fallen apart at this stage.
Yeah,
because it's just nobody there to maintain.
Sorry, maybe it's also a good strategy to target the pupils and the kids.
Oh yeah, because it's such a creative activity. And so it was Saskia Grünwasser was our master student that built these systems and that worked in the schools. And she also encouraged the students to participate by bringing their own materials. So we also have some photos of like broken buckets and things like that that students were bringing and planting their own vegetables in. So we had some spare seeds and just let the students participate.
A colleague of mine did a project here with our students, and they came up with an old jeans trouser, where they planted, I think, tomatoes or cucumbers. Or whatever.
Oh yeah, jeans are great. We use jeans a lot for the irrigation because they suck and like transport water really well.
Yeah.
So so jeans are really good for that. Yeah.
It's also, I think, an interesting issue to create awareness regarding waste management, to realize what you can find in the landscape and what you can make use of and what probably is not as good.
Yeah, mainly like plastics and things like that that are littered everywhere. If you can use them for a purpose, then they're also just gathered up automatically. Like the students were running around just grabbing bags and bottles and all kinds of stuff.
Yeah, that was
build these systems.
That was another question I had on my list. What about the problem of especially small plastic particles, as we now more and more realize how problematic they are especially for soil systems, where there is hardly any information, very little research done so far. But what we found out in our research is that it has quite a short-term drastic effect on microbial community, therefore also functions. And that may feed onto the whole food web, and then in the end may also have a negative effect on crop growth.
Yeah, well, I mean, in this project, we work together with Bastian Winkler, who has been working with urban gardening systems for a lot longer than we have. And we were also not so sure about like soft plastics, like bags and things like that. And he also said, I mean, we used it or encouraged the use of it mainly for just retaining soil, but not as an internal part of the system, so that you can see it and also see when it's starting to fall apart and replace it. But one thing he did warn us away from very strongly was tires, to not use tires, because there he's seen studies that like materials from the tire and from the rubber have gone into the soil.
Yeah, it's often the additives that are problematic in the short term, but we saw actually pure plastics also have a negative effect without.
Oh.
Yeah, which I found interesting, especially for PE. This was astonishing, but also for polypropylene. So
okay. Oh, good to know. Thank you. I'll make a note of that.
We know a lot from, let's say, the negative effect of plastics from aquatic systems, but in soil systems, it's very, very little. So, and especially in the tropics, subtropics, of course, where waste management is somehow different. I think this is a new area which we have to consider. And making benefit of it is probably a very good way of managing the waste. Yeah.
Yeah.
Okay, I'll quickly check the Q&A session again if there is any question coming up. No. Is there any question from the contributors here to any of the other speakers? If not, I think we're almost at the end. So thanks again for all the contributions here in this session. And I learned a lot again, and it was a nice array of different topics from different parts of the world, from the beautiful Iran, Ethiopia, Uganda, India. So I'm looking forward also to this afternoon session, or late afternoon session on assessing farming systems at different scales. We'll look a lot into systems comparing organic and conventional farming, not only, but this is one of the focus points this afternoon. If you like, you're welcome to join. And thanks again. Enjoy the Tropentag, and yeah, hope to see you in person then next year. Bye-bye.